All right, the numbers seem to be stabilizing, so I'm going to get started. Welcome, my name is Mark Coleman, and I'm the marketing chairperson for the CNCF. Today, we're very fortunate to be joined by Alexis Richardson, who's founder and CEO at Weaveworks, and is also the chairperson of the Cloud Native Computing Foundation's Technical Oversight Committee. Today, Alexis is going to be telling us about more, better, faster cloud-native apps with GitOps. But before we get into that, a couple of house rules. For those of you who've been on earlier webinars, you'll know that normally these days we take questions throughout the webinar, but we're a little bit worried about fitting all the slides in this time. So instead, we're going to take questions at the end if we have time. What that means for you is if you have questions while Alexis is giving his presentation, please put them in either the chat window or the Q&A widget down at the bottom. And if there is space at the end, I will ask those questions to Alexis. Alexis, are you ready to start?
Yes, can you hear me?
I can hear you just fine. Take it away.
Okay, thanks everybody, and welcome to the webinar. Very happy to be here. And if you have any problems with the display or the level of volume, just shout on the chat window. We should be okay. So I work at Weaveworks, where operations happen. We are a Kubernetes-based stack. And we also work with Kubernetes applications to do monitoring, exploration, and deployment for your apps. I want to show you today how we learned to apply technology to make our business go faster, as promised by cloud native and continuous delivery, and how we discovered that we were doing something new, which we call GitOps. Well, newish. It's really part of DevOps, actually. A lot of what we're doing has been done before, but we're doing it in a sort of slightly more Kubernetes way. And if we're doing anything, it's empowering developers to share some of the operational responsibilities that are implicit in running a successful business. Businesses today want to have quick change, like Airbnb can improve their app much faster than intercontinental hotels, for example. And that comes from having a really tightly integrated development, operations, and business team together. And GitOps is really a tool for achieving that goal. How did we get here? I'm going to take you back in time now to the early 90s, which is a time that I remember, some of you may not, but I remember the great excitement in 97, 98 when Amazon was a new company and Yahoo was a new company and people were talking about IPOs and these things. And at the time there were 23,500 websites, and then there were 10 million in 2000, really big growth, and we thought it was amazing at the time, but it was just tiny compared to today. And I think if there's any lesson here, it's that technology can change a lot in a very short time, and the technology that we have is incredibly powerful today, and you can really only appreciate that by looking into the past. So let's do that. This is the first Yahoo homepage made by hand. As you can see, a small taxonomy of websites. A year later, Amazon have their homepage, which kicks off the e-commerce revolution. Excuse me, I apologize, I've got a slight tickly cough today. I'm recovering from a cold. And 96, Dell decided to copy Amazon with this particularly beautiful specimen to sell their computers online. And then a few years later, social media arrives, and we have MySpace, which is of course still going as part of Murdoch's News International empire. Facebook, just after that, originally called The Facebook, of course, as a university application. And then YouTube, which I think is a really big step forward. I was one of the people who thought YouTube was completely crazy and idiotic at the time, and now feel very foolish for thinking that, because of course, video is such an important application of the internet. Which leads us, of course, to Netflix, which had this original idea of selling or renting DVDs online, and then sending them to you through the post, which wasn't terribly successful, but soon morphed into a new business where they would stream videos to you wherever you were and whenever you wanted to see them, which is really quite a remarkable innovation, because of course then they realized they had to improve their service to a much higher level of availability than had been done before. Previously, people got very obsessed with reliability. They thought that it was very important to be like a bank. If you did a operation, it was important that it would be successful or fail in a clear manner. And if the system went offline, then customers would wait until it came back, just as you are happy to wait in a queue at a physical bank in the street, on the high street. But of course, with the web, things flipped on their heads, and people kind of didn't mind if things were unreliable, so long as they were there. And Netflix was trying to make money from the idea that somebody would maybe get home at the end of the day and want to relax. And in that moment of truth, when they were deciding what to do next, whether to have a snack, read a book, or watch Netflix, it had to be there. So they decided to make their system highly available in a way that was unprecedented. And they also thought that customers would tell them how to make it a better service. So they thought they would be very important to change very quickly, to iterate new improvements of their service based on what customers are telling them all the time about whether it was good, bad, or just okay. And so they had to do those two things together, availability and rate of change. And that's what led them to this new set of technologies that we're calling cloud native now, almost 10 years ago. This is a slide from a reInvent conference in 2013, looking back to that time, 2009, 2010, when Netflix was sort of really writing down those requirements for the first time. And I think this is the first step in moving us to a world where business change happens incredibly fast. And of course, not long after that, everybody wants to be like Netflix, and you have people like VCs, Mark Andreessen here, saying software is eating the world because software industry has invented new businesses to take on the roles of traditional businesses in almost every vertical. And they've largely done that by moving very quickly. And that's been sort of the basis of Andreessen Horowitz's investment strategy is big bucks move fast, dominate a category. And you can kind of do that if you have this ability to be available to everybody and change very quickly to meet people's needs. Which of course has meant that developers have become very important. And what is a developer? I used to be a sort of high priest. Now, I would say that really anyone who can merge a pull request on GitHub could be arguably a developer. And the industry has learned a number of DevOps practices to wire up GitHub, the main source of code in the public domain, to running applications using pipelines, continuous integration, continuous deployment pipelines, or CICD, so that Git can drive operations, so that you can make pull requests and they can be pushed through this pipeline into a running system. That's the thing that we've been calling GitOps. And in this graph, you can see the change in pull requests over time since 2010, which remember is when Netflix made that change to being a global, highly available service. And you can see that in 2016, there were 66 million pull requests. And I think the number of users on GitHub is something like 30 or 50 million today. Most pull requests happen internally. They're not public open source things. GitHub used to be a thing that was all about open source, and now it's open source and enterprise. So really a big shift there, and there's more to come. So to summarize the first section, cloud native is this thing that Netflix kicked off, and it's driving this new phase of growth, which I think personally is as fast moving, as important, as fundamental as the 90s web in the first place, much more important than anything that's come between now and then, except the possible exception of Amazon itself. Developers are now the owners of these applications, working closely with business, and operations and testing and UAT are starting to become roles for developers and not specialized roles that are not part of the developer picture. And continuous delivery is, of course, how we go faster, many changes per day, or in Netflix's case, thousands a day, or Amazon's tens of thousands. Okay, so that's the introduction. What about GitOps then? Which I mentioned a few times. What exactly is that? Let's have an example here. And the example I've chosen for you is the more or less deliberate but slightly accidental day that we blew up our own product, Weave Cloud, which is a tool for monitoring and managing applications on Kubernetes anywhere, GKE, Amazon, wherever you go. And here's a picture of the architecture. We've talked about this a few times in public, so it's not top secret. As you can see, there are many moving parts. And we are very proud of it. It keeps us very happy and is up all the time, except when a developer decided to make a change and remember very clearly sitting in the office one afternoon in the springtime and hearing the person say, the next thing I'm about to do will probably wipe out our entire systems. I remember standing up and saying, wait a minute, what are you saying? Why are you going to do that? And then I heard this click as the key was pressed. And then there was this rather sheepish voice saying, oops, I have indeed just wiped out our entire systems. And then we went into this kind of panic mode. And the team sprang into action. Luckily, we have people who are used to this kind of thing. But even more luckily, we had based everything on a new philosophy that we inherited largely from Google and partly from DevOps and partly from other things, where everything was stored in Git, and we could rebuild Kubernetes from it in 45 minutes. And actually, it took us just under 45 minutes to wipe out multiple zones, multiple stages, and get back to a fully running system, which can take customer requests. Obviously, it takes a while to load the data into that, but we were back to normal in a short space of time. And in fact, even today, that was in 2016. Now we've even got some of these changes down to a much shorter time and had some sort of smaller wipeouts with much quicker recovery. And we could only do that because we were using this combination of Kubernetes, cloud native, and this sort of Git-backed approach, which I'll explain more about in the course of this presentation. And so GitOps enables rapid recovery from disaster and high velocity change for developers doing these new cloud native applications. Or if you will, it's cloud native plus continuous delivery. And for people who want to go faster, it's pretty straightforward. You need to adopt two practices. You need to adopt continuous delivery, and you need to adopt cloud native technology. And you need to own the changes that your applications will have, your business will ask for, which means that developers need to be responsive when operational things happen. They can't wait for operations to sort it out, and vice versa. So this is why DevOps is kind of morphing into more of a developer-centric thing, an ops-centric thing. And cloud native isn't just about orchestration in Kubernetes, it's also about monitoring, observability, logging, tracing, CICD, release automation as well, integration with Git, and trying to join all that up into a single automated chain. So how do we do that? So continuous delivery, I've mentioned a few times, and obviously probably many people who are in this webinar know what that is. But let me spend a few minutes talking about it, just in case you don't. And it's really part of DevOps. And here is a slide that I found on the internet, because I didn't want to build my own history of DevOps, from somebody called Helen Beale, a company called Ranger Ford that does consulting around DevOps. And it's a really nice picture showing a history of different events that lead us to this kind of over 10 years sort of DevOps culture in which operations and development are part of a shared social responsibility across larger teams. And I think for me, the key moment in this, all of this, is probably the Velocity conference down here with John Allspaw and Paul Hammond back in 2009, presenting 10 deployments a day at Velocity conference. And you'll see why that's important in a minute, because 10 deploys a day for some people is nothing, but for many people it's still just science fiction. GitOps is part of this. So let's move on to that. So what is the GitOps saying? Sorry, DevOps is saying is we want to do automation to get acceleration. So what we can describe, we can automate and accelerate. It's really, that's the idea behind DevOps, as well as the combining of development and operations roles. And I mentioned, this idea that John Allspaw and Hammond doing 10 deploys a day in 2009 were kind of radical. Look at this slide here. You've got Forrester data from 2016. This is Robert Stroud, a superb analyst in the space, who did a survey in Europe and found that 23% of enterprises are doing one release a month or less, or fewer, which is not very many compared to Flickr in 2009 doing 2 to 10 releases a day. And so this just goes to show how far we've got to go in terms of the real world adoption of this. Everybody's heard the word DevOps, you see it everywhere, but it hasn't yet delivered the kind of velocity and continuity for everybody that Mark Andreessen's software is eating the world picture promises. And indeed, many businesses are still stuck, as it were, frozen in silos doing either dev or testing or releasing operations. They're not joined up. And the good news is Summer is coming. The sun is shining in the world of DevOps. This ice will go away, and cloud-native applications are heating up the space. Common tools, or when I say common tools, I mean, we're speaking to the CNCF audience here. Obviously, you've all heard of Kubernetes and Docker. Perhaps not everybody has outside of the segment, but it will grow. And these are becoming common tools. You know, these are the future, simplifying and accelerating how people use cases like machine learning, TensorFlow, or reactive computing like serverless, for example, and many other examples exist too. And this is all part of a shift from business online being just websites and e-commerce and some sort of social and some photographs and videos, which are radical in their day, to fully automated business processes, much more complex, rich, involving interaction, systems of engagement, as IBM like to call them, all powered by highly scalable engine rooms of code with Kubernetes and Docker underneath them. And that's what's going to help get everybody moving to many more releases a day. And so those are the cloud native technologies I mentioned, which is a good opportunity for me to mention the Cloud Native Foundation, whose job it is to curate and promote tools for cloud native. It's as simple as that. It's like an Apache of cloud native. It's where Kubernetes lives. It's where Containerd lives. It's where Prometheus live. And its focus is on microservices, containers, and dynamic orchestration, and the things that go with that. So far, that means 14 projects. I've got 13 of them on the left here. TUF is not shown. Weave, one of my company's projects, is heading towards the CNCF2. On the right, you can see some of the companies that are sponsoring it. These are the platinum sponsors, and as you can see, for the first time since the 90s, and this is a theme I'll return to, everybody's facing in the same direction and pulling in the same direction, which means there is an incredibly strong will to make these technologies badged on the left into just part of the toolkit for how you build the world of technology in the future, which I think is incredibly exciting. And we're going to see a lot of good things in the future because of this. So at the center of this is Kubernetes, which is now being supported by Docker and Amazon and Mesosphere and others as they've all joined into the CNCF. And as you can see, it's about orchestration, which is a way of dealing with how containers join together into larger applications, much as Linux runs processes in the old days, the operating system. But it's rather low level, so it's still quite infrastructural. And Kubernetes has things like this. This is a config file, for those of you who haven't seen one before. This is called a YAML file. YAML is short for yet another markup language. And what you can see here is a description of an app, a very simple one where there is an Nginx load balancer, a web server, and then underneath that there is a thing called RSS reader that does some work. And excuse me, this is an app that will be running inside Kubernetes, which is the application platform for this simple application, as well as for this more complex ones I mentioned earlier about machine learning. And the point about all of this is that Kubernetes allows you to describe the application in a way that can be stored in Git and validated against the running app. So you can actually, it's called a declarative way of writing down what an application is. It's a description of the application. It's a logical, sound, consistent way of specifying and then checking and enforcing what actually is an application in tools like Kubernetes. And there's what's possible with GitOps, these short recovery times from widespread crashes are only possible because Kubernetes and other technologies like it have this property of this kind of description, which we can use automatically, consistently, again and again, without making mistakes, and we can check that our system is correct relative to it. So that's cloud native and continuous delivery, which I say come together as GitOps for developers. So now let's talk about GitOps, which I'm claiming is the key to velocity. And here's a nice picture of recently retired Usain Bolt. So how did Weaveworks rebuild our own systems in 45 minutes. And I must stress the size and scale and complexity of these systems. This is a non-trivial thing. We use declarative infrastructure. We use tools like Kubernetes. I showed you an example of what that meant, and Docker and Terraform, these kind of these reusable things that can be composed into larger reusable things, which lets you take the whole system, including all the bits and pieces of describing it and all the tooling for managing it, looking after it, keeping an eye on it, monitoring all dashboards and so on, all live in Git and GitHub. And there's a full audit trail that allows us to go backwards and forwards in time, different snapshots of code and changes, and everything that we do, and I really mean everything, goes through the system as a pull request, and try and avoid doing things to the runtime system. It's always a pull request. And we can automatically check. This is another benefit of the GitOps approach, is because we're using these descriptions of the system, we can check if the system that we have in real life is the same as what's the desired source of truth in Git. So, and if it's not, we can say, help, we need to do something. We can enforce changes to do that change and bring it back to where it should be. So, for example, if the system doesn't have enough resources, because in GitHub it says it needs to be running on this many machines, we can give it more. And this is partly done by orchestration for you, but it turns out that orchestration is not sufficient to describe every case. So we've discovered this is a very useful tool to make sure that we stay on track. And so GitOps is part of DevOps. People who know DevOps are sort of laughing and saying, well, we've been doing this for years. And yes, absolutely you have. It's just reinvented for cloud native here. Config is code. Code must be version controlled, and so config must be version controlled too. And we said what can be described can be automated. So therefore, we must describe everything, including our policies, our monitoring, and keep everything in version control. And it's not a finished job. Kubernetes lets you describe some things. Weaveworks has developed tools that let you describe more than that, and there's still open-ended problems to describe more and more and more of the system in this way to get to the velocity that we want to. And so the GitOps approach has Git being where we keep the truth about our system in, and what that means is if something goes wrong, then that's what you roll back to. If it's your rollback state, your last known good state. It doesn't mean it's the running state now, because that may diverge. You can compare the actual state with the desired state and get diff alerts, which you may ignore actually sometimes. And you make changes to the whole thing by forcing changes in Git, because you're updating the desired state, not the running state there. And here's an example of an alert in Slack that we use using kubediff, which is saying Kubernetes has changed from where it should be. Excuse me. And so that's the kind of intro to GitOps. And what does this get us? Pretty cool, actually. Any developer can join the team, and if they know how to do pull requests on GitHub, they can actually use GitHub to make changes to the running system. And people don't need to understand all of the ins and outs of Kubernetes or Prometheus or all of the other tools we use to manage quite complex applications. Because remember I said, Weavecloud itself is a Kubernetes application. We live and breathe this every day. This is our dog food. Forgive me for mixing the metaphors up. But anyone can join this team and be eating delicious dog food straight away and shipping a new app and making changes very easily. What's more, they're all stored in Git, they're audited, they're validated, and we can go back in time if something goes wrong. And guess what? None of this is very new or clever. It just works. And it's a way of, this is much more important, I think, perhaps, is the way that we're joining things up. We're joining up continuous integration, testing, and dev, along with continuous deployment and release automation and orchestration and analytics, customer experience analysis and marketing, it all together into one sort of chain of work life cycle in order to help customers have a better time on our websites and up with our products, which is the most important thing. And this is I'm allowed one slide to pimp my product. Here it is, a subliminal advertisement. I'll just flash past that. Do check it out. So I've gone into GitHub at a high level now. I've set the scene with continuous delivery in cloud native. Now I'm going to spend a bit more time doing a slightly deeper dive into the different pieces of GitOps, hopefully to show you there's a bit of bit of meat there too. So there are 3 pillars of GitOps, as I call them. Pipelines, observability, and control. The pipelines must be complete, joining up CD and release automation and orchestration and CI, not just CI pipelines. Here's a picture of that. You can see ABCDE. App dev, build, then you build your containers because they are the idempotent, immutable, you can idempotently deploy them because they are immutable artifacts of deployment. And the deployment is a separate function where you orchestrate the push of an app to the cloud, and then you execute that app in your orchestration, e.g. Kubernetes on Amazon or Google or on your own machines. And this is a nice model because it implies that you can choose your own components. You don't have to use one person's solution for all of this. I think that's very important. You can choose Travis for CI, Docker for containers, Spinnaker for deployment, and Docker Swarm for execution, or you could use Google Container Builder for build and Containerd, Rocket for containers, and you could use Flux for deployment, and you could use Kubernetes for execution. So GitOps, what's key here is getting CD right as it happens. So because config is code and everything is config in the declarative way, and they must be version controlled, CD tools that do not record changes in version control are harmful. Because as you're deploying, you might make some changes to certain things as you discover facts about the machine. So you need to make sure that if you do that and you don't record them, you can't roll back. You don't have a true record of your desired state in Git. So one of the things that we did that's very important for GitOps is this, which is a picture of a slightly different from normal pipeline, in which we update config changes in Git as we deploy. And this uses a tool called Weaveworks, which is open source and is a Kubernetes native continuous deployment tool. And it sits there and it sits in front of your CI pipeline. So you can use Jenkins or Travis or Google Container Builder to do your container construction, your code compilation, all of your tests and regressions, and then you can stick the results in an image repo from where a deployment orchestration tool, which is really a set of agents, will pick it up and make sure they get deployed correctly into different Kubernetes objects, which could be services or nodes or other pieces of Kubernetes operators as well. So that's something that's slightly different from normal. Normally people do something which I call CI ops, which is when they run Jenkins jobs to do deployment. The problem with that is if it blows up, you're not sure what to go back to. You end up writing a lot of scripts which don't necessarily deploy in the right way and are hard to manage as you grow more and more people in your team. You really want it to be programmatic and integrated as part of Kubernetes. So that's what we've done here. We've got a tool which is an orchestration manager for deployment, which coexists very nicely with CI tools, but it gets you out of this world of manual brittle scripts that is so problematic at scale. Next slide here. So just to summarize the pipeline section, everything's a pull request. This is a really fundamental operation. Pushing apps, pushing changes is what it's all about. You want to do that as fast as you can. You need complete pipelines. It's no longer about just having a CI tool and then some kind of kludge deployment tool. You need to have everything in a single flow with an orchestration piece in between Kubernetes and CI to make sure that you have consistency and coordination between the worlds of services and code and clusters on the other hand. And it needs to be backed by Git for all the reasons shown here. It needs to be the right tool. And sophisticated deployment policies here means things like blue-green, canary, manual automation, staging, all the kinds of things that you might need to do in more complex deployments if you've got a larger system. So the second pillar is observability, which is kind of a buzzword right now. People get confused about whether it's the same as monitoring. Monitoring is a thing that you do. Observability is a property of systems. Why is observability important? One reason is that if we do a deployment, in a highly virtualized, managed for you orchestration system like a Kubernetes cluster, we may not immediately know if our deployment worked. Of course, monitoring and alerts can tell us if something went wrong, but how long do we have to wait for something to be known to have gone right? How do we validate that our releases are correct? And here's a nice tweet from a gentleman called John Arundel, who lives in the UK. Never accept pull requests if you don't have a way to verify that it does what's supposed to do. This is all the more important in a virtualized cloud-native infrastructure, and is a fundamental tenet of GitOps that you must have validated releases. And it's really a sort of TDD, test-driven way of dealing with production code. Let's remember, we are pushing into production here. This is not just dev. So observations, which is what observability is all about doing, are answers to questions. Did my deployment work? Can I go home now? Are my users happier because of the work that I'm doing? If I do a release, did it improve things? Or actually, maybe I'm making things worse. You know, it's not just about being told that something has gone wrong that you need to react to, but it's about knowing, understanding completely whether your system is in a good place, a bad place, or somewhere in between. It's about almost being a sort of doctor for your system. And if you're a developer, that means that you need to get comfortable with these operational concepts, because these are the things that give you these are your tools that give you symptoms that the application is healthy or unhealthy. And as I say, you must be able to check that it's healthy as well as just diagnose problems. And because you're part of a team, you need to have a common language and a coherent understanding to do that. You can't just live in your own world and say, well, this is telling me X. You have to, we need a language to describe what's going on. Another key point is, I mentioned earlier that Git in GitOps is the description of the complete system, ideally, and it's the desired state of the system. It's what we can roll back to. But very often it's not quite the real state. That's the runtime system. And unfortunately, the real state is different from what you can observe. Observation is your reality if you're an operator. So you've got these three different things going on. So you've got observability as your second source of truth to compare with your desired state, and both allow you to try and make guesses about what the real state is and try and enforce it to be something that's correct. Ideally, all three of these are the same, but they might be different. So that's how the GitOps philosophy makes these things join up. And to do whole system wellness, it's more than just monitoring. Talking about incidents, alerts, troubleshooting, debugging, so many different things. It's very much up to you to get the signal from the noise. Here's somebody who talks a lot about observability on Twitter. Her company, Honeycomb, specializes in it with tools for quite sort of deep, high cardinality debugging. As you can see, trying to draw contrast between operations and understanding here being sort of related, but not quite the same thing. And there's a long thread on Twitter there that you might want to read. So just to recap, fundamental property of an application, it's like availability, security, reliability, it's an ility. And if you want your system to be observable, you have to include that in the beginning of the design and rollout of every change that you make. Secondly, it's all about a holistic kind of whole patient preventative medicine way of thinking about the world and your patient, which is of course your app. And it's even psychological, asks questions of the application. And it's also about comparing desired and observed state and understanding when the differences are important. And finally, it's not the same as alerting. More alerts might make the system more confusing. Observability is about getting signal from the noise. So now I'm going to have a little digression, and then I'm going to talk about the last thing, control, the third pillar. And this is just to talk about the theory behind observability and control. And I mentioned already that it's a way to verify that our system is in the desired state. But what is an observable system? It's one that can be controlled by a control loop. That's what drives continuous delivery and improvement. And the thinking behind this begins in the 18th century, believe it or not, with James Watt, a Scotsman, who was the sort of Scots were the secret weapon of the British Empire in its heyday, doing all the smart stuff. Here is something called a governor, which is a feedback engine to prevent a steam engine from overheating, which is invented by James Watt, I think about 1780 or thereabouts. And much later, 150 years later, here is a Hungarian, born in Hungary at any rate, lived in the States, Rudolf Kalman, Rudy Kalman, who kind of turned all of that machinery and engineering into mathematics. And the Hungarians were also the secret weapon of the US empire in the 20th century. So it's a nice bit of resonance there. And here's a picture of the control loop, the feedback loop that Rudolf Kalman showed you was fundamental to more or less every engineering process at the time. And he did many other great things that expanded on this thinking, but he invented the term observability and controllability as dual concepts. And his system, his theory of control systems really expanded to encompass many things. And here's a picture from the early 80s, some people operating a large factory. As you can see, it's starting to look a bit like people are operating Twitter or Facebook, I guess, apart from the uniforms. So my claim is that we're still doing control loops. We have this pipeline that pushes a force of change through the system, but what we're driving is releases, and those releases must be observed and operated in order to complete the loop. That is what we are doing every day in GitOps. Release, observe, operate again and again and again. And so we can draw this as an actual loop now with Git pushing to a runtime system as a release. We observe the runtime system using tools like monitoring, and then we have a control system which either automatically checks through diffs or through people operating a system, make changes to it. So this gives us a ROODA loop, or you've probably heard of an OODA loop, which is another part of control systems theory: observe, operate, decide, act. And here we have the ROODA loop, which I think is a description of what's going on in the control systems theory that underpins GitOps. So now we can state again the GitOps story, which is that only what can be described and observed can be automated and controlled and accelerated. It's just the same as DevOps, just with a bit more refinement. Okay, so let me wrap up now by talking a bit about control. Control is what you do when you observe things that are in need of attention. And here it is on that ROODA loop again. It's the understanding and the action that come from the observations in the actual state that let you drive change through releases. Here are some examples of control. Service management, which is about taking action based on observing a service. Maybe you're changing the number of machines that can be routed to because you need more capacity for scaling up. Maybe you are doing a stage rollout, a canary rollout. You're seeing if something performs better. You're rolling out more of it if it performs well and less of it if it performs badly. Security is another example of control because, of course, you're controlling, it's the opposite of observability. You're controlling who sees what and preventing people from seeing things, which becomes very important as you scale to a system that has many different users and different roles. And another example is policy, rules, which let you audit change and obviously are declarative as well, like Kubernetes, and can be stored in Git. So things like network policy, application policy, etc. And here is a table which you can see in more detail on our blog post about GitOps, giving you different examples of observation and control and examples of what that might mean from a Weave Cloud perspective, because we're using that today as our example app, but it could be your example app. And there are so many different things that can happen here. It's an interesting space with much more to learn for everyone, absolutely including ourselves. One thing that we're seeing that's really interesting is dashboards are changing. So instead of dashboards being just about metrics, now dashboards are integrating different kinds of sources of observability like events, logs, errors, metrics, and they're focused on different tasks like managing a service. And they're also letting you take action based on a corrective action, hopefully remedial action, based on what's gone wrong or about to go wrong. So here's an example from Matt Klein at Lyft, who's the author of Envoy, talking about a sort of Envoy-centric service dashboard. And here are some other examples of control. I've got a lot of text on this page, so I won't read it all out for you, but I mentioned the diffs earlier. You can also use it for compliance. You can have performance metrics as you do a rollout, because you're in that ROODA loop of doing observability as well as doing releases from Git. And you can do this too. You can have auto scaling based on those metrics. You can do so much more. So just to wrap up on control, diffs, really important because you've got this link between observation and Git. Focusing on the different parts of a system that are important are a good way to reduce noise. Instead of being deluged with alerts, you can have views that just throw out everything except what's true for a particular service right now, like the red method metrics, request rate, error rate, duration, and correlate that with logs and other events of changes, releases, and so on. And I keep saying Git, keep everything in Git. We even put Grafana visuals in Git. So that was fairly swift tour of GitOps. I hope it wasn't too detailed and too fast. I wanted to get to the end in time for a sort of quick conclusion and some questions. So just to wrap up, what is GitOps? It's for developers. It's about simplifying continuous delivery for cloud native apps. It's about joining things up, not just CI and development, but also adding orchestration, Kubernetes, and observability tools like Prometheus to the story, and logging tools and Fluentd and OpenTracing and Jaeger and more besides. And it's about speed, both delivery and recovery. And here's a link to a blog post which introduces a series of posts talking more about this that you might want to read. It's also social. Nowadays it's just incredibly important to work in teams. Not everybody can be present all the time. It's a 24/7 environment. We have to take turns. We have to share, and that means a different set of disciplines around how we work. And GitOps is very much tuned to that. It's about integration. It's about joining up these different stages, combining different sources of truth and understanding how they relate to each other, which leads you to building new kinds of dashboards and new tools. And so the future, what does the future hold? As I said before, we're still at the early stages of unfreezing whatever's blocked us from doing DevOps all the time. Business is still not happy. They want tech to be moved more responsive. We see more consolidation going on around testing, dev, and ops into single teams. Automation is becoming within reach for many people. Today, one release a day is just crazy talk for many, but it will become normal soon. The GitOps lifecycle will change this, and new app types. Nobody cares about any of this unless you can actually do something useful with it. So, machine learning and other things are other use cases that can really pull us into the future here. So, come and talk to me or anyone else in the team about this at KubeCon and Cloud Native Con. I will be there. You can sign up if you haven't already. Please do. And get in touch at Alexis at Weave.works or Monatic on Twitter if you want to talk to me in person about anything I talked about today, or indeed about anything at all. And that's us, Weaveworks, where ops happen. Thank you very much for listening. I think I've got time for some questions now. Everybody.
Thank you very much, Alexis. It's a quiet/shy crowd, and we've had no questions so far. So I can only imagine that you explained it so well that there couldn't be anything left to understand. But I have a question of my own. So obviously, this is something that you've developed as a practice over time, and most practices come with headaches. Normally, in the sense of having to do things in a new way which doesn't feel natural. Have you, or mainly the development team, found yourself sort of going back to the old way of doing things when the shit hits the fan, so to speak? And how do you deal with that?
No, quite the opposite, actually. Going back to the old way of doing things would kill us. When, as you put it, Mark, I'm quoting you here, the shit hits the fan.
Yeah.
We absolutely have to rely on these techniques, otherwise things go much worse, much more quickly. Very, very important to bear that in mind. There are gotchas. I mean, people who've paid close attention to this world will know that secret management is challenging because secrets are things that are secret. You don't want to put them in a place which is social. So we don't store them in Git willy-nilly. We might encrypt them, or we might use a tool like Vault, or another secret management service. Another area is, of course, the whole business of how you deal with different databases. You're not going to have a database stored in Git for reasons that I probably don't need to explain. Yes, I see lots of questions popping up on the chat.
Yes.
Should I just answer some of them?
Yeah, if you can read them, you can just go ahead and answer them.
Okay, I'm just trying to make the window a bit bigger.
Oh.
So going out, I see Mark Kuzum, different configs stored in Git. How do you manage the recipe to replay it all from scratch? We use Terraform, Ansible, and Kubernetes to do that. It is described on the blog post. If you go to the blog post that I linked a few slides ago, it takes you into lots of other places where this is explained in written detail, so that you can delight in the depths of all of this and reimagine for yourself. How do you integrate Git with Helm generated resources? So Helm is an interesting tool. It's not compositional, and it doesn't really support custom development over time. It's much more useful for a kind of quick getting started thing. So we are in the process of figuring out an integration with Helm and Flux, which is the tool I mentioned for continuous deployment and deployment orchestration earlier, which there are 4 or 5 different ways to do it. It's a little bit subtle, but where we want to get to is the idea that a service has the same, a chart has the same status as a Kubernetes service in terms of reusability in Git. I can't give you more details than that right now. Does this work for offline deployment in private cloud? Yes, Andy, it does. None of this is tied to public cloud at all. This is all tied to using Git and Kubernetes and CI. So we use GitHub and we use key.io, but you could use Git on premise, you could use GitHub Enterprise, you could use key.io on premise and so on, and Docker Hub and all these things. Sorry. Excuse me. Was going to ask about secret management. That was Dave. Hi, Dave. We've covered that. Bill Summers, do you have a white paper or other documents explaining GitOps briefly? I can share with my DevOps team. Yes, absolutely. Please go and look at the blog posts. The link I provided is the starting point. There are 3. There'll be probably a 4th. And not
I just put the link in the chat, Alexis, so you can follow that one.
Thank you very much. Just start there and just dig in. And if you don't find what you want, just get in touch. Please do. I'll just put my email address on here as well. Okay, let me just make sure I'm. There you go. Okay, Kiran. What are your suggestions for state-based applications, including a few terabytes of data to move towards GitOps? So what we do is we have extremely large amounts of data. I mean, we actually store a kind of TiVo or a video of your application's evolution for the full lifetime of the application, if you want it. I mean, not everybody wants that, of course. But when we can do a demo that shows you what our own app looked like, 2 years ago, we can just replay it. So we're storing a large amount of data in S3 and DynamoDB on Amazon. In GitOps, we largely do that by the GitOps, declarative infrastructure, not describing that data. That is data that we load consistently after we've got the main application up and running, which is not the same as being stateless. We've got a lot of highly stateful applications running inside Kubernetes as multi-tenanted, scalable, data-driven apps, but they are backed up by S3 and DynamoDB. How do you suggest managing data stores like databases? I hope I've sort of covered that. I think that they're out of band like Vault. How do you manage third-party dependencies in the build process? That's a related question, because obviously, wiring up third-party services is something that you want to do consistently. All I can say is I'm not the engineer who should answer that question. In fact, I'm not an engineer at all. But you could probably send me an email and I can ask people what the state of play is there, because we do have a few, I think, in our builds. Any other questions?
It looks to me like that's it.
Does that mean we can stop?
That means we can stop indeed. Yeah, all that's left to say is, Alexis, a huge thank you for this. This is your second webinar. We appreciate that. And I see some thanks coming through in the chat right now. Thank you also to all of you who attended and then asked questions at the end. That is also very much appreciated. I do not off the top of my head know what the next webinar is going to be about, but we have moved from monthly to bi-weekly, so there must be lots of goodness coming. You can look at the events page on cncf.io to find out what's coming up. That's it now. Thank you all and goodbye.
Bye-bye. Bye-bye. Thanks, Mark.